Okay, we are going to do this one first because we can just use the u sub. Let u equal to the inside. I will just put down u equal 2 times cosine x minus 1. And we know this is a good choice because if I differentiate both sides, the derivative of 2 cosine x minus 1 is negative 2 sine x dx. And I want to isolate this dx. I can just divide this on both sides. So I get dx equals to du over negative 2 sine x. And I can take this integral to the u world, right? So this is going to be the integral. On the top, we still have the sine x. And on the bottom, we have the square root. And the inside is our u, so I'll put the u right here. And for the dx, it's that, so I'll just put down du over negative 2 times sine x. And from here, we see that the sine x, they cancel each other out nicely. So we are completely in the u world, so that's good news. And let's see, we have this 1 over negative 2. Therefore, let me just take that to the front, right here, negative 1 over 2. And then we have this integral, and we pretty much have 1 over square root of u. And we know square root is 1/2 power, but since this is in the denominator, so we will write this as u to the negative 1/2 power. And we are in the u world already, so that's the u. And everything is in the u world. I can integrate this easily, add 1 to the power. Negative 1/2 plus 1 is positive 1/2, and divided by positive 1/2. It's the same as saying multiply by 2 over 1. And you see that this and that cancel. And that was the integration step. And we see that the answer is pretty much negative u to the positive 1/2 power for the result of the integration. But we have to go back to the x world, so it's okay. We can just put this right here. And since this is just the square root, let me just put that down. And the u inside is 2 cosine x minus 1. And we are all done, so let's put a plus c right here. And of course, if you like, you can also add a c there, but it doesn't really matter. So that's it. Now, how about the second one? You might be thinking, okay, we have tangent x on the top. That's kind of like bothering us because we like to have sine and cosine in integrals, right? Because they get along really well. It's okay, it's not that bad because yes, we can just look at tangent x as sine x over cosine x. So it's a good idea. Let's do that. This is just the integral. On the top is sine x over, I will have this additional cosine x. Because sine x over cosine x, that was the tangent x. And then I still have this part, which is the square root 2 cosine x minus 1. And of course, don't forget your dx. And now you might be thinking, okay, can't we just use the same u, just the inside 2 cosine x minus 1? And it's pretty much the same process from here. Yes, it's going to work, but let me tell you that if you let u equal to just the inside, in fact, you will have to do another substitution. So let me show you. Here, I will actually use letting u equal to the whole square root, and still going to work out pretty nicely. So let me put this down, let u equal to square root of 2 cosine x minus 1. And the idea is that sometimes it's actually a good idea to give it a try that let u equal to the whole square root. And maybe you could have done that earlier and you should try it and let me know. But I want to do these two different substitution in these two different situations for you guys. Anyway, from here, we do our usual business. I will differentiate this, so we get du equal, the derivative of square root of something is first 1 over that, right? So I'll just put down 2 square root of 2 cosine x minus 1. Because remember, the derivative of square root is 1 over 2 times the square root of inside, right? But the chain rule says I will have to multiply by the derivative inside. And the derivative of 2 cosine x minus 1 is negative sign for the cosine, so we have negative sine x. But that's a constant multiple, so I will maintain that. And the derivative of negative 1 is 0. So this is my derivative of the inside. And then I will put down the dx here. And the reason I want to do that is because it's easier for me to look at this and then isolate the dx, right? And you see the 2's cancel. And to isolate the dx, I will just multiply by the reciprocal on both sides. In another word, we see that dx is equal to, this is going to be on the top now, namely square root of 2 cosine x minus 1, and then over negative sine x. And of course, that's with du. And we can just try to take this to the u world. We'll see that this is the integral. On the top, I will still keep the sine. And on the bottom here, we have this cosine x. Let me just write that down. And this time, this is the whole u, right? The whole thing is the u. So I'll just put down multiply by u. And the dx is that. So I'll put down 2 cosine x minus 1 in the square root. So let me also write that down. But if you look at this right here, it's actually the same as u, right? And in fact, I would like to put this u on the top because this and that are going to cancel each other out. So this is pretty much u over negative sine x. And then we are in the u world, so we put on the du. And from here, you see that, yes, the u's cancel each other out. Sine x and also the sine x cancel each other out. And now, let's take a look. We have this negative. Bring that to the front first. And then we have the integral. On the top, we pretty much just have 1 now. And on the bottom, we have cosine x. And this is du. Well, in the u world, x is not invited. So we cannot really do any integration yet, but it's okay because if you look at cosine x, let's just refer back to our definition of u. We chose that u is equal to square root of 2 cosine x minus 1. Well, I want to isolate cosine x from here so that I can put that in here and we will be in the u world. Let me do that by squaring both sides first. And we see that we have u squared equals to, this and that cancel, which is 2 cosine x minus 1. And then we add 1 on both sides, so I'll write down 2 cosine x equals to 1 plus u squared. So I just put the 1 over there, and then I wrote this down first, and then I will divide by 2 on both sides. So it's the same as saying cosine x equals to 1/2 times that, 1 plus u squared, like this. So I will put this down for the denominator right here, right? You see, we will have now negative integral 1 over, that's the denominator here, which is 1/2 1 plus u squared, like this, multiplying the parentheses, and this is the u world, and we're so ready to integrate. We have this little complex fraction, 1 over 2. It's a really easy fix. Let's just multiply the bottom by 2 and the top by 2 so that this and that will cancel. And then we pretty much have 2. 1 over 2 is pretty much just a regular 2. Anyway, I will put this 2 to the front. So this is negative 2 integral 1 over 1 plus u squared du. And this is negative 2. And the answer to this part is the inverse tangent. And we are talking about the u, so let's put on the u. And lastly, I will just put down the u back to the x world. So this right here is the same as saying negative 2 inverse tangent. And I will open a parentheses. And the u is square root of 2 cosine x minus 1. And we are all done. So let's put down plus z right here.